In this video, we will go over a suggestion by you guys, a video on infinite limits. Welcome or welcome back to my channel, Numerics with Nadia, and let's get into our lesson objectives for today. By the end of this lesson, you guys should be able to define limits and recognize when they occur, understand vertical asymptotes through graph behavior, evaluate one-sided and two-sided infinite limits algebraically and visually, and recognize when a limit does not exist due to infinite behavior. If you guys haven't watched the rest of the videos in the calculus playlist yet, I would encourage you guys to watch those first. I will tag that playlist right here for you guys. And let's get into some definitions to start off our lesson today. So first off, what is an infinite limit? An infinite limit describes the behavior of a function that increases or decreases without bound as the input approaches a specific value. So looking at this formally with the notation, if the values of f of x become arbitrarily large as x approaches a, then the limit as x approaches a of f of x would be infinity. If the values decrease without bound, or if the values keep getting smaller, then the limit as x approaches a of f of x would be negative infinity. So these limits do not exist in the traditional sense, but the symbol infinity describes their behavior. So if they're getting arbitrarily large, it would be infinity, and if they're getting very, very small, it would be negative infinity. Now, why does this happen? This usually happens, and infinite limits are usually associated with vertical asymptotes. So depending on the graph of a function, we'll be able to tell how the vertical asymptote is going to affect the limit. So now we'll get into our examples for today. For our first example, our function is 1 over x minus 2. And what we're looking for here is the limit as x approaches 2 of 1 over x minus 2. And as we know from our introduction to limits video, we need to assess the limit from the left-hand side and from the right-hand side. So first off, as x approaches 2 from the left, we see that the values of f of x are getting smaller and smaller and smaller. So we would say that f of x approaches negative infinity. Now we'll do the same analysis for the other side. As x approaches 2 from the right, we see that our values are getting larger and larger and larger. So we would say that f of x is approaching infinity. So the left-hand limit and the right-hand limit are not equal here, so our limit would not exist, but we can see that we have a vertical asymptote at x equals 2. So that's our first example. Now we'll get into our second example for today. For number 2, our function here is 1 over x plus 3 squared, and here we are looking for the limit as x approaches negative 3. So we'll do the same thing as our last example. We're going to analyze the behavior as x approaches negative 3 from the left and as x approaches negative 3 from the right. When we look at the graph, as x approaches negative 3 from the left, we see that our values are getting bigger and bigger and bigger. So that would mean that f of x is approaching infinity. We'll do the same thing from the right-hand side. As x approaches negative 3 from the right, we can also see that our values are getting bigger and bigger and bigger. So that means that f of x would be approaching infinity. So here from the left-hand side and from the right-hand side, they are equal. So our limit here would be infinity, but we can also see that there is a vertical asymptote at x equals negative 3. Now we'll get into our third and final example for today. For number 3, we have f of x equals 5 over x. And our graph is shown here. So we are looking for the limit as x approaches 0 of 5 over x. Just like our last two examples, we're going to split this up into two. We're going to first off look at the limit as x approaches 0 from the left. So as x approaches 0 from the left, we can see that f of x is getting smaller and smaller and smaller. So f of x would be approaching negative infinity. And if we look at the other side, as x approaches 0 from the right, our values are getting larger and larger and larger. So as x approaches 0 from the right, f of x would be approaching positive infinity. So here, since the left-hand limit and the right-hand limit are not equal, the limit would not exist. And we can also see that there is a vertical asymptote at x equals 0. That wraps up our lesson for today. Thank you guys so much for watching. Please let me know if this answered your question. Feel free to comment any other questions down below as well on this topic or any other video topics you would like to see. Please like this video if you enjoyed it, share this video with a friend, subscribe if you haven't already, and I will see you guys next time.